Hello, my dear students. So, welcome to our new lecture. Now, in this lecture, we are studying modern periodic law and about the modern periodic table. Okay. Now, in the previous lecture, we have studied about the Mendeleev's periodic table and the merits and demerits of the same table. Okay. Now, we know that a lot of scientists have contributed in classification of the elements. In the time of Mendeleev, only 63 elements were known, okay? And at that time, the discovery of electron was not done, okay? It was not happened yet, okay? So after the discovery of electron, scientists started exploring the relation between the electron number of an atom and the atomic number, okay? Once the electrons were discovered, okay, we know that the atom have three particles: electron, proton and neutron, where electron is a negatively charged particle. Okay, when it was discovered, at that time new concepts were evolved, okay, and a lot of scientists used that concept in classifying the elements. Okay, the atomic number in Mendeleev's periodic table only indicated the serial number of the element. So in Mendeleev's periodic table, the numbers which were used, they were actually the serial number of the element. But after the discovery of electron, a new concept, that is atomic number, was in use. Okay, in 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiments done using X-ray tube that the atomic number Z of an element corresponds to the positive charge on the nucleus or the number of the protons in the nucleus of the atom of that element. Okay, this revealed that atomic number is a more fundamental property of an element than its atomic mass. Accordingly, the statement of the modern periodic law was stated as follows. So, in the year 1913, the English scientist whose name was Henry Moseley, what he did, he performed certain experiments, okay, with the help of X-ray tube, and he found out that the atomic number of any element is nothing but the positive charge present in the nucleus of that atom. Okay, in short term, it is the number of protons present in the nucleus of that atom. Okay, so, what is atomic number? It is the number of protons, that is positively charged particles present in a nucleus of any atom of the element. Okay. So, what he did after studying all these properties, he find out a new law and he named that law as modern periodic law. What was the law? That the properties of elements are periodic function of their atomic numbers. So this particular statement is modern periodic law. In the previous classification, we have seen that Mendeleev considered the atomic mass as periodic function of the element, but more concise and more applicable law is that the periodic function of the element is atomic number. Okay, and by using this particular concept, Henry Moseley had classified all the known elements, that is, all the known 118 elements in a table, and that table is called as modern periodic table. So, in this lecture, we will study the structure of this table, that is, modern periodic table. Okay. Now, here you can see this is the modern periodic table. Okay, this table is composed by several blocks and rows, columns. Okay, there are rows and columns in this, and different colors are used to represent the elements in this table. Okay, so we'll study the structure of this table in this lecture. Now you can see there are vertical columns. Okay, in all 18 columns are there, and these columns are called as periods. What they are called? They are called as columns are called as groups. Okay, so all the 18 columns are nothing but the groups of the modern periodic table. Okay, so question may come in the examination, how many groups are there in modern periodic table? The answer is 18 groups. How many groups are there? 18 groups. So group 1, 2, 3 and so on till 18. Okay, whereas the horizontal rows are nothing but periods of the modern periodic table. These horizontal rows are called as periods. What they are called? They are called as periods. So how many periods are present in a modern periodic table? There are in all 7 periods present in modern periodic table. Okay, number of periods is 7. Okay, now you can see here that on the left top corner of every box present in this table, okay, a number is used or number is placed, and this number, that is 1, 2, 3, 4, 5, 6, 7 and so on till 118, that is 118. This is nothing but the atomic number. Okay, this number on the top left corner in every box or in every part of this particular table, okay, this is nothing but the atomic number. Okay, and the alphabets or the group of alphabet which is there in this table, these are nothing but the symbols of the element. Okay, so atomic number and then symbol is used. So H is the symbol for hydrogen. So below the symbol, name of the element is also given. Okay, and below the name of that element, what is given to us? The atomic mass is provided. Okay, so in this table you can see H, that is hydrogen, okay, which have atomic number 1. Okay, it is the first element of the modern periodic table. Keep this in mind, that hydrogen is the first element of modern periodic table, whereas oganesson, that is element having atomic number 118, is the last element of modern periodic table. Now in this table there are several blocks. So in all 4 blocks are there in the modern periodic table, that is S block, D block, P block and F block. Okay, so S, P, D and F, there are 4 blocks. Okay, block S, that is S block, is nothing but the elements from group 1 and group 2. Okay, so elements of the group 1 and group 2 are in S block. Then elements from group 3 to group 12 are in D block, and elements from group 13 to group 18 are in P block. Okay, and these elements are placed in these blocks. That means the properties of elements lying in the blocks are different from the another one or corresponding one. That means the property of the S block element differs to the property of D block element, and the property of D block element differs from the property of P block elements. Okay, now S block elements are alkali or alkaline earth metals. What type of elements are there in S block? Alkali or alkaline earth metals are there in S block. Okay, then in the D block, transition metals are placed. Okay, so all the elements which are there in the D block are nothing but transition metals. They are transition metals. Okay, so scandium, titanium, vanadium, chromium, okay, mercury, gold, platinum, iridium, all these are transition metals. Okay, whereas in P block you will find non-metals, inert gases and metalloids. What type of elements are there in P block? Non-metals are there, inert gases are there and metalloids are there. So the elements which are along this zigzag line, okay, that is boron, silicon, arsenic, tellurium, then polonium, antimony, germanium, these are metalloids. So what are metalloids? You have been taught about this. So metalloids are nothing but the elements which have the property of metals as well as non-metals. So any element or any substance having the property of metals as well as non-metals are called as metalloids. So these are the example, these are the elements which are nothing but metalloids in the modern periodic table. Okay, and the group 18 elements, all the element which are present in group 18. So this element, helium, neon, argon, krypton, xenon and radon, these are the inert gases. These elements are called inert gases. Okay, so group 18 elements are inert gases. Okay, we will discuss about all these elements briefly. Okay, so inert gases are those element which have complete octet. The last shell of this element have a complete octet. Okay, and they have, and the inert gases are non-reactive elements. Inert gases are non-reactive. So helium, neon, argon, krypton, xenon and so on. These elements are non-reactive elements. Okay. Now you may have a question that the F block, it is separated from the modern periodic table, but it is actually a part of the modern periodic table. You can see that the element from 57 to 71, okay, this particular component of the modern periodic table, you can say this particular box, okay, 57 to 71, all the elements of 57 to 71 are written over here. Okay, that is lanthanum to lutetium. Okay, so these are the elements. Then from 89 to 103, 89 to 103, again this is the element from the 7th period and 3rd group. Okay, so element number 57 to 71 is placed in 6th period, okay, and 3rd group, which is called as lanthanide series. What it is called? Lanthanide series. So this 14 elements are from lanthanide series. Okay, and the elements from the 7th period and 3rd group, that is from 89 to 103, are the elements from actinide series. They are the element from actinide series. Okay, so this 28 elements are from F block. Okay, and these elements or F block elements are called as inner transition metals. They are called as inner transition metals. Okay, so what we have studied in this particular lecture, we have seen the structure of modern periodic table. There are 4 blocks: S block, D block, P block and F block. Okay, in all 118 elements are there in the modern periodic table. Okay, which are arranged in vertical columns called as groups and horizontal rows called as periods. Okay, so in modern periodic table there are in all 18 groups and 7 periods. Okay, in S block you will find alkali and alkaline earth metals. In D block you will find transition metals. In P block you will find non-metals, inert gases and metalloids. Okay, and in F block you will find inert transition metals. Okay, and the group 18 of the modern periodic table is called as zero group. Why it is called as zero group? Because it is the group wherein you will find all the inert gases, and inert gases are non-reactive in nature. Okay, we will briefly study about the modern periodic table in the next lecture. Okay, until then, goodbye.